Hello there, and welcome to this EMBL-EBI webinar series called Take a Rest from Manual Searching. This particular webinar will be looking at an introduction to programmatic access to tools and databases at EMBL-EBI, and my name's Andrew Cowley. So in this webinar, I'm going to have a quick look at what we're trying to do, why we're here really. I'm going to talk about why we should consider programmatic access. I'll say how web services work, and then how you use them in practice. I'll talk a little bit about web service clients and give a demonstration before going on to some tips and pitfalls, and then just a final few slides about where to get help. So what are we trying to do? Obviously, it's bioinformatics, which we define as the science of storing, retrieving, and analysing large amounts of biological information. And this has loads of uses, from molecules to medicine, to looking at human variation, and it enables us to do lots of things, for example, maybe farming smarter. Now at the EBI, we have an awful lot of data resources and services. I'm not going to go through this whole slide here, but you can just look at them at the EBI website sometime. But just to show that we cover the whole range, right through from genomes to systems biologies to small molecules. And importantly, there are things like literature searches and expression data and things like that. So why should we consider programmatic access? You might say, well, the websites are really nice and easy to use at the EBI. I hope you think so. They're very nice, they're easy to use. You can have a very visual way of inputting your data, and the results interfaces can be very visual as well and very interactive. And you also have access to the latest versions of our tools and our data because our website is directly talking to our latest databases. However, there are some disadvantages to just using the browser. Most people can only really do one task at a time through the website, and you might have very good ambidexterity and be able to do more with multiple windows, but generally that's not going to happen. Repeating the same analysis over and over again on a browser can get very tedious. And through the websites as well, there tend to be rather limited workflow capabilities. Sometimes you can take the results of one job and send it into another one, but the means of doing that and the flexibility of doing that on a website are inherently limited. So what else could you do? Well, of course, you could install the tool and the data on your own computer or on your own server. And that way, you can run as many tasks as you like at the same time, just as long as you've got the power for them. And of course, this way is also really easy for you to integrate into your own workflows using your own data. It's a really flexible approach. But of course, there are some big disadvantages to having to do a local install of all the tools and the data. Firstly, you might need a bit more expertise. So not everyone can install a BLAST server. Likewise, you might need some extra privileges. If you're trying to run this on a server, you might not have the permissions you need to install things. Not inconsiderably, there are also compute and storage requirements. These programs can take up a lot of memory, and they are very, very big databases that we're using. But perhaps the biggest disadvantage of having to install things on your own computer and your server is just how do you keep all of that data up to date, and how do you make sure that you're always using the latest versions of programs? It's a real pain, it's quite hard. So there's another approach that we can take, and that's what we're talking about here when I'm mentioning things like programmatic access. And what that involves is interfacing with our servers programmatically. This allows you to use our compute, so it allows you to use the big servers that we have, as well as the very latest versions of the database that we hold here. You can run many tasks simultaneously with this approach, and it's also fairly easy to integrate programmatic access into a workflow or your own website or your own front end. Of course, nothing's perfect, so there are some disadvantages to programmatic access as well. It's not completely unlimited in terms of how much you can run at the same time, although it's still one of the best methods of accessing the most you can. You do still also need a little bit of programming knowledge or scripting knowledge or command line knowledge. And you are still using our data. That's usually a good thing, but it's harder for you to, example, use your own custom data with our services through programmatic access. So how does this all work? Well, in a traditional browsing sense, you have a user who talks to a computer, and then you go over the web to the servers at EMBL-EBI. And the servers at EMBL-EBI feed back a result to that web page, and the user can view it. So what programmatic access is doing is kind of removing the user from the equation and just having the machines talking to each other. And it does that by hijacking that same protocol that was used for displaying the web pages. So one of the definitions of web servers is that, or web services I should say, is that it's the part of the server interface that responds to a defined response request message system. So there's a predefined system that has controlled vocabulary and known terms and functions which the server knows to expect and can respond to. Now there are two main types of this message system. One's called SOAP and the other is called REST. And both of these can act over HTTP, so the same thing that's been serving your web pages. SOAP stands for Simple Object Access Protocol. And what this does is wraps up the requests and responses in an XML envelope. You can look up the definitions, for example, parameters, by looking at what's called a WSDL or WSDL. This stands for Web Service Definition Language. And each service in SOAP has a clear definition and a WSDL. And SOAP has been historically quite popular, but now it's becoming more and more superseded by the other method, which is REST. REST stands for Representational State Transfer. And in most cases, you can just use URLs and HTTP verbs, for example, get, post, put, and delete. This is a bit lighter weight than having to manage all those XML envelopes, and it also tends to be a bit quicker to process as a result. And a quick note that REST is actually a style rather than a protocol. So you tend to describe services as being RESTful rather than they're implementing a REST protocol. So there are some examples of services using REST at the EBI. One of them is the EBI search. So if you've gone to the EBI website at any point and typed in something in the search bar, that's using the EBI search engine in the background. And you can access that programmatically too, by searching for entries across our whole collection of databases. On here, you can see the URL for just doing a simple search with a query called Globin. There's an HTTP, there's a sort of root, so ebi.ac.uk/ebi/ws/rest, and then there's the query. And if you did that in a browser, which you can do, you get a programmatic response, in this case, an XML style document containing the results. This is easy for a computer to progress. So you can just quickly test out REST examples just by changing the text in the URLs. Another example of a REST service is dbFetch. And this is an engine which allows you to retrieve entries across our databases. So here is the URL for fetching a uniprot protein, and that has the ID of WAP-RAT. So if you just type in that URL into a browser, you'll straight away get the default response, in this case, which is a Swissprot format file, and it's just plain text. So you can start using that straight away, or processing that straight away. Now I'm just going to mention something about synchronicity. So synchronous web services are a bit like throwing in the ingredients for a cake into an oven, and then straight away getting back the cake. This is very nice for services that can be run quickly. But if the task takes too long to run on our servers, you might put in your ingredients into the oven. But if you're waiting for a response straight away, you'll get back an uncooked cake. So instead, there's something called asynchronous web services. And here you might put your ingredients in. And instead of returning back a cake, you'll return back like a ticket or a job identifier. Then you can go back to the server and say, is my cake done yet? Is job ID done? And the server can give a response saying, still cooking, still running. So then you might leave it a little bit more time before asking again, is my job done now? And then the oven coming back and saying, it's ready now. At which point I might say, okay, I'm going to retrieve the results of this job, and I'll get the results of the job. So how do you know which parameters you can use with our services? The first port of call is to go and look at the documentation, obviously. And each service should have a link to the documentation on the service page. If you're using SOAP, you can also look directly at the WSDL, and this will describe some of the parameters. Now, unfortunately for REST, while there is an equivalent of the WSDL, which is called a WADL, a Web Application Description Language, it's not mandatory, so REST services might not have one of these. So instead, what you can usually do is query the parameters programmatically as well. What does that look like? Well, many web services will return details of parameters when they're queried. So if I was to type in the following URL, www.ebi.ac.uk/tools with a capital T, /services/rest/ncbi blast, and then I'm saying, what parameters can I use? I'll get back a programmatic response listing all of the parameters. So I don't need to know them off the top of my head. I can go into further details by, again, using the same route, but this time using parameter details and then the name of a parameter afterwards. So in this case, I'm querying what the parameter program can be done with, can be used for. And so again, I get back an XML document in this case with the name program, a short description of it, and some values further down the page, for example, blast P. Now you can build these into a website that uses the Swagger framework as well, in order to create interactive documentation. So they've done that at the EBI search, and if you go to https://www.ebi.ac.uk/EBI search/swagger.ebi, you'll see the Swagger documentation page for the search engine. And what you can do here is you can have a look at the different methods, and then you can type in example parameter names. So here I'm looking at the parameter called query, as we saw from our earlier example, and I'm testing out what would happen if I put in the parameter value of globin. So this is saying I'm going to query with the term globin. And then I can click send, and it will generate a response from the server. So this is what the response from the Swagger server looks like. It tells me what it's going to send across the browser with the URL that it's sending. It gives me the REST URL, including some header information. And then beneath that, you can see the response body. And this, like we saw before in the example, contains our results. Now, talking about results, most web services also give you the option of different results. So there might be different formats, for example, the raw text, or it might be XML format, or maybe a list of identifiers, maybe some images. So if we want to distill the whole process down, there are 3 general steps to looking at tools and services programmatically. The first thing is to just query and find out what the terms are, what the steps are that we need to do. So you might want to list the parameters, get the parameter details. Once you know that, you can run a job using the input parameters. So you'll have to use your email, maybe do some values or program details, and you'll return back a job identifier. You use that to check the status of the job, whether it's running, for example, or whether it's now finished, and then you get back the results. And you can list the results that are available, or you can specifically say, I want to get a particular result type back. So how are we going to do this in practice? There are many, many ways of using web services. I'm not going to cover them all here. But generally, what you want to do is incorporate the calls to the server into some kind of program or script. And then you can run this from the command line, or it can be called from your own website or application, or perhaps a workflow tool. Many EMBL-EBI services come with example clients as well, so they can be used as a guide for you to incorporate into your own services, or sometimes they can just be used on their own from the command line. The clients are available for most services in a range of programming languages. We have some available in Python, Perl, and Java. Though I would say that Python is becoming a very popular choice. So going forward, we're looking, I think, to provide most of our clients in Python. And these clients are usually freely available to download and modify and use them, both to learn from or to use them within your own service. So looking at the sequence analysis tools that are available through web services, we have documentation and clients available at the following address: www.ebi.ac.uk/tools with a capital T /web services. So now I'm just going to run through what a typical BLAST search might look like. So some of you might have already seen this page. It's slightly changed visually nowadays, but this is what the NCBI BLAST website looks like at the EMBL-EBI servers. And what you can do is you can select the database that you want to search against with the BLAST tool. You specify the sequence type of the data you're going to search. There's a box for you to input your sequence, your query sequence, into the form. And you also set the parameters, for example, the program name. And down here we've got BLAST-P listed as the program name. When you click Submit, you'll get taken to a screen that looks like this. It says, "Your job is currently running, please be patient." And it gives you a job identifier. Now, if you keep watching this screen, you'll see it refreshes about every 2 seconds. This is the same as that polling back for the thing saying, is job ID ready or not? And only when the results are ready will this page get replaced with the actual results. So here we see what a typical results from a similar BLAST search would be. We have a summary table. And looking at the top of that, we can see the results for job, and then we've got this job identifier. As you can see from that, it contains the name of the program. It contains a letter which talks about something about how the job was submitted. And then there's the date. So it's already useful to remember when the date of your job submission was. Below that, there are several results tabs which allow you to see different types of results for your BLAST search. One of those is the visual output. This shows where the alignment is occurring in the sequences. And as you can see, it's a graphic. Another graphic is the functional predictions tab, which talks about the functional and families predictions from Interpro. I'm not going to go into these in great detail here. There is another webinar which covers this, and there's more information on the website. So how do we do exactly the same thing, but with web services? Well, to start, you'll need to download a client. And in this case, I've downloaded a client from the Tools Web Services page that I gave earlier. The next step might be to run it without arguments, to check for the usage or to look at the help information. And then when you're ready, you can carry out a normal search. And there you would need to include your email address. This is quite important because we might need to contact you if something's gone wrong with the job. So it's really important that you use a real valid email address. You need to include information about the database, just as we saw on the web form. You need to pick a sequence type or an S type, just like we saw again, pick a program, and then finally carry out the input sequence. So it's just like submitting the same kind of job on a web form, but we're just going to use the command line instead. So I'm going to try that live, see how that works out. Okay, so in this case, I've opened a terminal, and I'm actually running this inside a virtual machine that's running Bioinformatics. And Bioinformatics has pretty much everything you need to run web services out of the box, really, so it's quite nice. So if you remember what we just did then, we were going to look at running the client on its own. So I have downloaded a client. In this case, I've downloaded the Perl one, but it might as well have been the Python one. And it's called NCBI BLAST _LWP, which is the REST version. If I run that on its own, I get a load of help information. So just scrolling up through that, it says NCBI BLAST, rapid sequence database search programs utilizing the BLAST algorithm. And then it talks about some parameters. So it already tells me the required parameters, program, database, S type, and some kind of input sequence. And then there are some optional parameters. Now I could go and investigate those with the param details option, but I don't think we need to do that now. So in order to run a job, I'm going to type the name of the program. I'm going to give it my email. I'm going to give it a database. I'm going to, in this case, search the Swissprot database, which is uniprot kb_Swissprot. I'm going to give it a sequence type, so it's S type, it's protein. Program, I'm going to run blastp, just like we did on the website. And finally, I end with the name of my sequence, my query sequence that I'm wanting to search against the Swissprot database with. So we'll hope that runs. Okay, so the first thing it's returned is my job identifier. And now it's telling me it's running. So in fact, I only needed 1 2-second polling here. It found the finished results quite quickly. And now it's creating different results files. So I can see the out.txt result file at the top. All of the files are prefixed by the job identifier, so you always know which files are resulting from which job. I've got the input sequence that I use for the job. I've got the IDs, which is an ID list. I've got XML versions of the results. And following that, we have a whole bunch of different graphic results, which correspond to the graphical tabs we saw on the website. So you can literally get exactly the same information that you could have got from a website analysis purely by using the command line and web services. This comes in very handy. I'll just go back to the presentation now. Okay, so we're back. So this was my screenshot of what happens just in case. And so luckily I didn't need to do that. The demonstration worked okay. So you don't just have to run one service on its own. You can run several services together. So the one that we just tested was quite similar to the first line here. It was a blast search using some kind of input. I mentioned before the dbfetch service, which enables you to retrieve entries, the whole entries onto your computer. And there are also many other services we offer. For example, multiple sequence alignment tools, of which kalign is an example. So here we've got 3 different web services commands. We've got a blast, we've got a fetch, and we've got an alignment, multiple sequence alignment. So running these one after the other will perform a blast search with a query. Then it will fetch the actual results of that into your own computer, and then it will allow you to use those as input for a multiple sequence alignment. Now, of course, this being the command line, and in this case on Linux, you can chain these things together. So in just one line here, we've carried out a whole workflow analysis experiment, starting off with just our single input, and we'll end up with a multiple sequence alignment with homologous sequences from your inputs, and also that will automatically generate things like a phylogenetic tree. So it's a very powerful thing. In just one line, you can do whole analyses. And of course, you can chain these together using graphical tools as well. So there are tools like Taverna, tools like Galaxy, and you can just plug in those web services, WADLs and WSDLs, in order to generate easy to use, easy to compile workflows, which could then be shared, of course. So I'm just going to go on to talk about some of the tips and pitfalls when using web services. So of course, people are going to start away asking, how do we parallelize these things? How do we batch run them so that I can run them automatically and don't have to sit there staring at a screen? Well, firstly, I'm going to say, don't go mad. Please go and check the terms of use first, because most of things have some kind of limit on just how rapidly you can run them, how many things you can run at once. If we're talking in terms of the sequence analysis tools, we generally have a limit of 30 simultaneous jobs. So if you submit more than that, you might be affecting how quickly your jobs run on our servers. And if you submit so many jobs as to be disruptive, and our servers are under heavy load, we might end up having to temporarily block you from submitting more jobs. If that ever does happen, we'll try and contact you, and do feel free, of course, to contact us and let us know if you have particularly heavy usage that's required. If you're using a third-party tool, many of which exist in order to help you batch run or parallelize web services, for example, Blast2Go or run IPR scan, check whether they're already submitting multiple jobs for you. with just one instance. So I think something like Blast2Go will already submit perhaps 25, 30 jobs just in one instance. So you can't run more than one Blast2Go instance at the same time, or you'll go over our limit of 30 simultaneous jobs. So how do you actually end up parallelizing or batch running these things? One way is to use a script to automate new job submissions. So what you're doing is replacing that input file name with a new input file name. And what you can do is you can run those. You can use a simple looping script that checks. And when jobs return the status of finished, you can submit a new job so that you have a running batch of up to 30 running at the same time. And you can quickly churn through long files, long input lists this way. But also have a look at the clients. Many of the clients have some kind of shortcuts in order to make their use in batch running more easy. So for example, the BLAST search I showed earlier has a parameter called multifast-A, or as a flag for multifast-A. And this allows your input not just to be one file containing one sequence, but instead it can be a file containing multiple sequences, in this case in FASTA format. And what will happen then, when you give that file to the client, is that it will work through them all sequentially, automatically for you, so you don't have to keep replacing the input file each time. It will do that. So one way of using this to really maximize your throughput through web services is to split your great big input into 30 files of roughly equal size, and then you can launch 30 simultaneous multi-FASTA jobs. So that will run 30 of these files, and each file will contain a list of inputs which will get run through simultaneously. So very quickly it will churn through, running 30 times in parallel through a long list automatically for you, so you don't need to do anything else. Some other tips are to bring back only the results that you need. So by default, if you don't specify anything otherwise, all of the outputs are sent back. So we saw when we did that on the terminal that it created lots of different outputs, and some of them arrived quickly, for example the plain text output, and some of them arrived more slowly, for example the vector graphics, which were quite large. So you can reduce the space that you need on your computer, and also the transferring time, by just returning outputs that are of interest for you. So you might just be interested in a hit list of results in terms of your ID list. You might be interested in just the plain text BLAST report. So you can use commands to just return particular results. So in the case of the BLAST service, we have a parameter called poll job. And this is what you do to go back to a result that you've previously carried out and to return just the results that you're interested in, or do other things to it. So in this case, if we use poll job together with an out format parameter, and then you give it the job identifier, we can return just the IDs. If you're not sure what job types are available, and this is a good thing to check because not all of the tools produce the same types of output, there's a parameter called result types, which our clients recognize with the job identifier and will then spit back the types of results which you could then use in your out format to pull back. So a typical check would be to run this once manually, see what kind of results you get back, and then specify just the ones you want. Or if you're running it manually, you might check what results are available before pulling them back. So you might want to include a little loop in your program to check that the result type is found before you try and retrieve it, just to optimize the process a little bit. In terms of error messages, as you can imagine, there are different stages where these can occur. One stage could be in the client. So if you've downloaded the client might just simply refuse to finish running. Maybe there's a bug in the client, but we'd hope not. But please let us know if you do find one. But more commonly, if you've missed a parameter or you've used the syntax slightly wrong, the client will throw an error and hopefully tell you a little bit of information about what you can do to correct that. And in those cases, nothing's been sent over the servers. So the next stage is then what happens when you send something to the web service or to our server. And you can get errors here. You can get HTTP errors, or we also have an input validation check on our server's tools, so that if you're missing an input, for example, you've not actually fully typed in your sequence, then our tools will check that and they won't bother taking it down to the level of the actual compute clusters. They'll say, we don't have all the information we need, and it will throw an error or a failure message, and that'll come back to you. And then the final kind of level of error messages are after the job's got all the way to the compute servers, it's running on the machines, and then the tool itself, the program itself, has some kind of problem. And in this case, the tool might return an error running or completing the job. So common kinds of errors. You might get returned an error when you check the status of a job with that's called not found. When you see this, check that you've got the job identifier correct. If you've mistyped it or copied it, pasted it wrong, then obviously you won't find it. But also check the submission date. We only store results for 7 days, and beyond that time they're completely deleted, and I'm really sorry, but we can't retrieve them once they've been deleted, so you'll need to submit the job again. Another error is just straight error or failure on the status, and this tends to happen when the parameters or the input isn't correct, or that it's failed the validation check on our servers. Now finally, you might get what you think is the correct status of finished, but when you look at the results files, you find an error.txt file. Now this is an indication that something's gone wrong either with the program or with the way that the program was launched on our servers. So the first thing to check then is the contents of the error message. That usually contains some kind of clue as to what's gone wrong. Check things like your input. Have you used the correct format? I've not talked about sequence formats here, but they're quite important to getting the right format for the right tool. Maybe your input's just too large and the program's run out of memory. Finally, check which tool you're using. Some tools aren't suitable for certain types of input. If you've struggled with any of those, then you can always contact us. And if you give us the job identifier, we can go and look at the job on the servers and find out what's gone wrong. So on that note, what do you do if you want to get some help? Well, most of the tools on the website have documentation available through some kind of help and documentation link. We also have a help desk that's available through feedback buttons or help buttons on the site or contact us buttons. But there's also a URL, www.ebi.ac.uk/support, which will take you straight to the support form where you can type in a query and it will go to our support team. There's a kind of manual for running web services and running the commands, how to install the clients, how to install any prerequisites for the clients, for example, Java modules you might need, in the current protocols and bioinformatics. And in that's unit 3.12, it's called using EMBL-EBI services via web interface and programmatically via web services. And I really do recommend that if you want to list sort of cookbook almost in some ways of different commands and running lots of different services available through web services. If you do find our tools useful and you've used them to conduct your own science, then we'd be very grateful if you could cite us. The latest reference we have for that is called Programmatic Access to Bioinformatics Tools from EMBL-EBI Update 2017. And that's found in Nucleic Acids Research Web Server issue. There's a DOI here for you to look at later if you want to reference like that. So that's the end of this webinar, Introduction to Programmatic Access to EMBL-EBI Services. I've just left some useful links on this page, again just the support web form and some DOIs for some relevant papers. In the rest of this series, we'll be looking at a whole range of other services in more detail and their programmatic access. And do have a look on the Train Online site, which will host the files used in this presentation later as well. So thanks very much for watching and listening.